Today's daily LeetCode problem of the day is kth largest element in a stream, number 703. For this problem, we want to design a class to find the kth largest element in a stream. So we want to take note that the kth largest element is in sorted order, not the kth distinct element. So we want to implement the kth largest class, where kth largest initializes the object with integers k and the stream of integers nums. And then we're going to use our int add function to append the integers val to the stream and return the elements representing the kth largest element in our stream. What does this mean? So we're going to design a class k that finds the kth largest element in a stream. What is a stream? A stream in this situation basically just means we're going to continuously receive new numbers as our program runs. So we are starting, nums is going to be equal to 4, 5, 8, and 2. This is our true input. 3 is k, and 4, 5, 8, and 2 is the integer array nums. So under input here where it says kth largest and then add, what it's trying to tell you is that this first number is your kth largest value, and add are all the numbers we are planning to add before we get new inputs. So for this problem, we can use a minimum heap to keep track of the kth largest amount of elements. So for example 1, our kth largest is equal to 3, meaning our minimum heap is only ever going to contain 3 values. A minimum heap is simply a priority queue that is going to prioritize the amount of values we want to store in it. So we're going to have a priority queue of at maximum length 3. If we go over this, we want to remove a value. If we're under this, we want to add a value. So as we initialize our minimum heap, we are going to say, all right, are we less than k values? Yes, add number. Less than k, add number. Less than k, add number. So now that we're equal to k, we're going to look, is this greater than whatever our smallest value is? Because if, for example, 2 was a 5, we would remove the 4 and add this extra 5. And our minimum heap would be 5, 5, 8 instead of 4, 5, 8. Because 2 is less than, we don't add it to our minimum heap, and it stays as 4, 5, 8, meaning that the kth largest element, or the third largest element, is 4, and we return 4. Next, we look, and we have 3. 3 is not greater than 4, so we return 4. Next is 5. 5 is greater than 4, so our minimum heap is updated to be 5, 5, 8. So we return 5 because that's our third biggest number. We then add 10 to our minimum heap because that is greater than 5, 5, and 8. And because it's a priority queue, it's already going to reorganize itself. So our priority queue is going to be 5, 8, 10. So third largest number is still 5. Then we're going to add 9. So our new minimum heap is going to be 8, 9, 10, meaning 8 is the third largest number. And then 4 is smaller than 8, so it's not added. 8 is our third largest number. So we can see that down here. We add 3, we return 4. Add 5, we return 5. Add 10, we return 5. Add 9, we return 8. Return 8. So let's go ahead and implement this. So for this problem, we're going to use a minimum heap. And our minimum heap is basically going to be a priority queue that is only going to store a k amount of elements. To do this, we're simply going to keep track of how many elements are in our priority queue. And if we have a k amount of elements, we are going to check, basically, when we add a new one, is this one greater than whatever the last element in our priority queue is? If so, we will pop whatever is at the bottom of our priority queue and add that number, and that will be our new, and then we can discover our new kth largest integer. So how do we implement this? First, we're going to initialize a public priority queue, and this is going to be our min heap. We're also going to have a public int k. Now in our public kth largest, we can identify our min heap and our k. So we're going to have min heap. Up here, we have to make sure we identify it's going to store integers. So min heap is going to be equal to a new priority queue. And then, yeah, so k, this dot k is going to be equal to k. Now we're going to fill our min heap. So for each num in nums, we are basically just going to add it to our min heap. So we're going to have min heap dot add our num, and then we can check if min heap, if the min heap dot size happens to be greater than k, meaning we have more than the amount of elements we want, we can simply do min heap dot remove, and this will remove the smallest value. So in this case scenario, we have 3 as our k value, so we'll push 4 to our heap, 5 to our heap, 8 to our heap, 2 we are going to also add to our heap. However, heap.size is going to be greater than 3, so we're going to min heap.remove, and it's going to remove our 2. So our min heap is going to start as 4, 5, 8. After that, we are then going to do our add function, as we're going to add the first 3, or whatever the next integer is. In this case happens to be 3. So what we're going to do in our add function is first check if our min heap dot size is less than k. We can add another integer because we need the kth value. Or if our min heap dot peak is less than val, we are going to add it to our min heap. So min heap dot add val, and then again we're going to check if our min heap dot size is greater than k. We are going to do min heap dot remove, and that will simply remove whatever the smallest value is. We will then be able to return min heap dot peak, which will return the kth largest integer. So if we run this, passes our test cases, and if we submit it, passes all solutions. Let's go ahead and do this in Python. So for our solution in Python, first thing we are going to do is define our minimum heap and our integer k. So we're going to have self.min heap. That's going to be equal to an empty list, and our self.k, which will be equal to k. We're then going to go through nums and add all these nums to our heap once again. So for num in nums, we're going to do, for this problem, we're going to need to use a heap queue. So heap queue dot heap push, and then we're going to pass it two things. We're going to pass it self.min heap and our num. So this is just like doing our priority queue in Java. This is our heap, and we're simply doing heap.add basically, and we're adding it to this list, which happens to be our minimum heap, and this is what we're adding to that list. We're then going to check if the length of self.min heap is greater than k. We are going to do heap queue.heap pop, and I'm pretty sure we need to pass it self.min heap. And so this is going to pop whatever the smallest value is in our minimum heap. So again, going to our add function, we are simply going to check if the length of our self.min heap is less than, the length of our self.min heap is less than k, or our self.min heap of 0 is less than our val, which is the same as checking what the kth largest element is currently in our minimum heap. And if it's less than the current value, we need to replace it. So we're going to do heap q dot heap push, and we're going to push our value onto our minimum heap. Then we're going to check if our self.min heap, if the length of our self.min heap is greater than k, we need to remove an element. So we can do heap q dot heap pop on our self.min heap. We will then return our min heap of 0, which is going to be our kth largest element, as we only ever keep k amount of elements in our minimum heap. So if we run this passes our test cases. Make sure you add your self dot in front of your min heap and your k, because they're public, and it passes all solutions. So thank you, and follow for more daily LeetCode solutions.